Good afternoon, ladies and gentlemen. My name is Hafiz Sheikh, and I am the business head for Manufacturing Today India magazine. On behalf of ITP, Manufacturing Today, Rockwell Automation, and BDMA, I welcome you all in today's webinar. ITP Media Group publishes more than 100 weekly and monthly magazines and has a wide portfolio of market-leading digital properties. We also organize more than 100 business and consumer events and conferences globally. Manufacturing Today is India's leading magazine, which focuses on people, process, and technologies for small and large manufacturing organizations. The manufacturing industry is now being at the forefront in embracing and implementing new technologies. In this disruptive age, the agility of the company to adapt new technologies will define its success. We have today industry's experts to speak about their experiences. We start with the first panel discussion on the topic of reimagining the chemical enterprise with intelligent automation. With this, I will quickly introduce two panel members for today. We have Mr. Ravindra Raju, President, Manufacturing, Tibet Fertilizer and Petrochemical Corporation. We have Mr. Pushkar Rege, Vice President, IT, UPL Limited, formerly known as United Phosphorus. We also have Mr. Dilip Shawnee, Managing Director, Rockwell Automation, who will be also the moderator for this panel. Over to you, Dilip.
Thank you so much. It's a good thing when technology comes together because we rely so much on it. Well, first of all, I would like to welcome everyone to this very important event for a very, very important industry. Some say that chemical industry is the mother of all industries. Now, whether you believe in that or not, there is certainly no denying the fact that there's a critical importance that is placed on chemical industry in our economy and in our lives, right? And if COVID has done one thing, it has rapidly accelerated and amplified this importance. And then there are geopolitical factors which are also making it compelling for us to de-risk ourselves from some of the external, reliances that we have, from countries where we import from and so forth, and attain self-reliance. There are estimates that are put out over there. It's anticipated that the size of the Indian chemical industry is going to grow from, a shade below 170 billion to about $300 billion by 2025. And what's even more impressive, even more staggering, is that the positioning. I was making a comment about the size of the Indian chemical industry, which is going to grow to nearly $300 billion. But what is even more important, even more impressive, is that it's going to jump in its position, the pecking order in the globe, where we are placed at 6th slot today. We're going to jump 3 slots and become the 3rd biggest country in terms of the size of the chemical industry, right after China and the USA. Now, oftentimes in business and management parlance, we often talk about being number 2, number 3, or number 1, number 2 in the globe. This is one industry that really, really is well on its way to go over there. We are extremely proud about it, but this is not just going to happen. There isn't a magic wand, that you can simply just wish yourself into that state. One thing that has happened, I would say a couple of things that have happened because of COVID. One, COVID has certainly accelerated, the dependence on a whole host of, industries which are basically, supported by the chemical industry. So, that is certainly for sure going to be accelerating the growth. The other thing which COVID has done, pretty much across the board in our lives and in our businesses, it's proven one thing for sure, that digital technologies, are here to stay. They are here to transform life and business as we've known it. There are varying degrees of adoption of digital technologies across the spectrum. But one thing which is for sure is that, no one is fighting, whether or not, there is going to be a play for digital in the business context or in our lives, right? Now, when you talk about, India jumping from, being outside of the top 5 to being number 3 country globally in terms of size of the chemical industry. For such a transformative change to be brought about, and for us to add new capacity, and for us to make existing capacity more productive, for us to avoid a lot of risk factors, because there are inherent risks that are involved, in certain parts of, chemical processes. It's and then in order to create talent, that can really help fuel the growth of the industry, to reskill people appropriately. There's a whole host of aspects that need to be relied upon, and I would submit to you that digital technologies have a role to play pretty much across the spectrum, be it on the talent side, be it on capacity creation, be it around enabling remote collaboration, be it around end-to-end supply chain optimization, and giving you transparency into your operations, etc., etc. Digital has a core and central role to play, and intelligent automation, which is what we are going to be talking about, right? Is going to be core and central to what we will be able to achieve. I should point out over here that when you talk about creating such ambitious plans, and creating essentially the underpinnings of such ambitious plans, you got to be thinking about de-risking. You got to have an emphasis on creating resiliency, having agility in your enterprises, right? And also making sure that there is an appropriate amount of focus that is put towards worker reskilling, and also aspects which are equally important around warehouse management, supply chain, transportation optimization, monitoring, so on and so forth. In short, my submission to you is there is a whole host of factors that need to be dealt with, and the one common thing which is going to run all across is the digital thread, right? So I'm delighted to be the moderator of today's panel. We've got two outstanding leaders with us, both of whom have been intimately involved with the Indian chemical industry. Both bring different points of view. One from the business perspective, another one from technology and enterprise perspective. And I look forward to the next 25-30 minutes, and we would try and cover a wide range of topics. So to kick the whole thing off, I'm going to put my first question to you, Mr. Raju. We're talking about technologies. My question to you is, what are some of the technologies that an industry like chemical needs to adopt, particularly to build a resilient enterprise?
Thank you, Hafiz. Thank you, Mr. Dilip Sawhney. Sorry for the late joining, a little bit late, but anyhow, we are
You're well on time, sir.
We are on time. Thank you so much. And just to give a brief background, I head the group manufacturing of Deepak Fertilizers and Petrochemicals. And we have about 5 manufacturing locations, and we have 3 business lines. One is the industrial chemicals, which includes petrochemicals, which includes fertilizers, we bulk fertilizers, and then we also have technical ammonium nitrate. So this is a kind of a business line. And coming to this topic of digital world, you have rightly said, it is going to touch each and every one of us in the whole arena of things, what we are going to do as we move forward. And the COVID pandemic, while we have gone through a challenge, it has also, put up some opportunities to us to move forward on the digital side at a faster pace, realizing the advantages. Every one of us had some doubts. How do we, the core manufacturing, which we have, the run-of-the-mill manufacturing plants, what is its utility? How do we move to the digital world? And what kind of technologies we need to adopt? So a typical example which I can share, what I, as a group manufacturing head for Deepak, how did we see this journey? We had seen that the digital world has come up with solutions in bits and pieces. What has happened is the software guy is a different fellow, the hardware guy is a different fellow, the analytics comes out with a different guy. Then we have this domain expertise is lying with the factories which are there, and also the technology suppliers. So how do we integrate this to make sure the digital technology gives its business case to the entire world? Now, for the first time, we started struggling. How do we develop a business case to move towards the digital world? Then we said that no, after seeing the various experiences, we have to take the leap forward to have a minimum investment on a proof of concept. So what we in the industry, in this particular industry, we have done, we have chosen a particular plant, we have chosen a particular area, we have rolled out a proof of concept end to end. So what is its going, what is its outside, what is the objective? The objective is to have 4 objectives. One is how do we improve the EHS? How do we improve productivity, that is efficiency? How do we improve quality? How do we improve capacity and reliability? So in these 5 parts, which are not any manufacturing company, what do we do in this digitalization? Where exactly we are going to touch? What is it we are going to achieve? So this is where we focused on, and we found, fortunately, enormous amount of scope in every area, because the more the amount of censoring, the more the amount of online information which is coming in, the more the amount of real-time data which was coming in. We have seen a lot of opportunity for improvement in every area, because in the EHS area, you have right-time decision-making processes by which you will be able to avoid any fugitive emissions. You will be able to avoid incidents and accidents. So there is a huge lot of improvements which were flowing in when you have this coming in online. The second area, what we have seen, the capacity and reliability. As the trends have started coming in, we saw very clearly different types of variations in production, in downtimes that are getting monitored through this, because we have already implemented a proof of concept in one of our plants, and we saw the ranges can be optimized to a certain level that we could get the advantage straight away. If suppose a parameter was varying from X to Y and Y to X, and there is a frequency, so by just about doing a little modification or little optimization on that would give an enormous benefit to you when you are real-time trending this information. And the other area where I have seen is that my managers get this information as an email when there is an alarm. Suppose there is an alarm which has to escalate, automatically it is online escalation process has started by which people start taking actions on it.
Yeah.
The reliability side, all of us, many of us who have started implementing this, I have seen it very clearly. The vibration monitoring, the sensors of vibration monitoring of these equipments are giving me an indication how the equipment is performing, what time the equipment has to be taken into a downtime. It is predicting that this equipment is going to fail if you don't take action right now. So there are some threshold limits which are fixed. Okay. There are clear-cut guidelines which we have seen that these are moving in on the maintenance reliability side, on the capability capacity improvement side, and on the EHS side. Okay. This is how the future technology we should see how we can use these technologies, whether it is the digital online technologies which we have adopted. We have done a company with a company called Coaxis, and we have also done several exercises with other companies like Aviva. Like we also had some interactions with Haldertopso, who is a technology domain supplier in ammonia plant. We have an ammonia plant.
Yeah.
We also have a technology supplier called Haldertopso. And Haldertopso is about 60% ammonia technology suppliers in the world. Correct. So they have come out with a digital solution on how to optimize the energy consumption. So that is an area where we are working on. How do we save energy, optimize on energy? And they are telling us that by digital technologies, you will be able to, it will impact nearly 4% on the bottom line. So how do we relate That 4% EBITDA. So anything around 2% is a huge amount for any business. 2% EBITDA is something very, very huge, in a manufacturing company. So that's where we are looking at least to 2%. Can you put this technology into place in such a way that we link it with a success fee? Where we are building a business case, understanding these technologies better. We have done the proof of concept. We would like to go to the other plants for implementation of this proof of concept. Once we have made it robust, because there are certain doubts, as you rightly said, people capability is a major issue.
Yeah.
People owning up is a major issue. Skilling is a major issue. So people who are there 40 years, 50 years in this old manufacturing plants, for them to change into a process where everything is on a computer and then you start doing a math and math is controlling you rather than your own brain. So the 40 years experience, what we call, within 6 months is getting converted into a math. And then saying that whole experience, I can do it here, but I want to capture your experience. So there is a threat on the skill which they are seeing. So we need to handle that part of it, move people away, saying that there is enough scope to use the human brain into value add activities rather than those mundane activities which we were doing earlier and in the analytical front.
Sure. No, you've given a very wide range of you've given a very wide range of insights and ideas. I particularly like the 4 aspects that you covered, starting from EHS to productivity, efficiency, quality, and then on to enhancing capacities and on the people side, because at the end of the day, it's a massive change management undertaking. So I'm going to come back and explore with you that aspect in particular. Yes. But let me come to you, Mr. Rege. If you really look at it, implementing digital technologies, in an industrial setting, right? There are critical considerations, from a risk management perspective. How do you look at ensuring cybersecurity and safety of operations, in the context of chemical manufacturing?
Thank you so much. Thank you for having me on the panel, and great interacting with Mr. Raju. So, from the IT side, first of all, let me start with the chemical boom. You mentioned it. The last 5 years, I'm seeing India really growing, and I'm wondering why we are still not in the 3rd position. And I'm sure with all of us together and with IT and the IT fraternity we have in India, it's a tremendous advantage to have partners and everyone in India. It's a bone of sense. So I would like to start with saying, and the problem statement that was put up by Mr. Raju, in IT, probably we have to restructure our orientation and probably merge or align the IT and the OT technologies to make it one platform. And that's probably one of the strategies that I would recommend or advise. And it means even people strategies, it means putting the teams together, and obviously starting with problem statements. So I like Mr. Raju's definition, and I would urge most companies not to use technology for the sake of technology. Begin with a problem statement, begin with smaller goals maybe. But remember that if you do not start these things, you probably are not going to meet those objectives for your company or for your group, or for the country itself. The bigger point is obviously, once you start with these things, you have to worry about the security side of it, as you put it. Because with OT, and that's where the worry is, you have to make sure that emphasis on cyber protection, like including firewalls or whatever. I do not want to make a technological jargon topic here, but even simple things we've found over the period has been ignorant in the factories. People do not look at upgrading or even doing vulnerability tests. I'm sure you've had those challenges right from awareness. So I would say begin with awareness and get your factory people to be aware of what are the threats, because cyber is no longer it's a personal threat today. Also, it's a known deal for everyone. The COVID period has only accelerated it, but it's been there all the time. So yeah. I think the emphasis we need to do on our plants and our the areas, whether the traditional ways or even newer ways of building cyber controls, even safety factors that you talked about in the environment health safety. It's no longer wired technologies, and you can even have softwares that can build and resilience around that. But that would be the area of focus that I would suggest. Do not just expose your technologies and networks till your platforms are built. Of course, it doesn't take long. You have partners today that will help you go there very fast.
Sure.
The other area probably you should leverage is probably I'll just take a minute more. I know is about remote monitoring and how you can use these technologies to probably bring in safety factors. And today, as you said, you probably receive emails to know what's happened, but you can also proactively and real-time dashboards. You can have manless, operations, and people have used this. And many factories in our global presence we are talking about how to introduce these POCs. So begin with the POC, and I'm sure it's a collaborative work that we need to do with business partners such as Mr. Raju, and collectively we can get there.
Well said. Thank you so much, Mr. Rege. Excellent insights, and supporting but very complimentary to the point of view that we heard from Mr. Raju. Mr. Raju, I'm going to come back to you. You're talking about how you need to be really putting emphasis on the change that you have to bring about within the organization, particularly on the people side. How ready do you think large chemical businesses are in terms of executing and undertaking transformations of that scale?
Yeah, so good. First of all, let me also thank Mr. Rege for giving us the IT bit of it, which is very important, and organizations are working towards integrating IT as a business tool rather than IT as an IT. You just for the sake of it or for the heck of it, you don't get into IT. I think IT has to have an objective and a problem statement. I think that's a good start which we should have, and we need to progress there. The second important area is I told you about people, transformation. Now, the transformation journey, which I saw practically at my company, in one of the units which I was driving this initiative. We deliberated a lot, and we said that let us keep the production manager. He should be the owner of this, not the IT manager, not the technical manager, but the guy who is on the shop floor. Let us move the ownership to the shop floor manager. The moment I shifted this to the shop floor manager, he is very skeptical. See, the moment you shift the responsibility there, he will come out. What am I going to get? What is that you are going to give me? I'm doing this. I'm doing this. I'm monitoring this. I'm monitoring this. I have my own MIS. I have my SAP system running. I have my this system running. So what is this going to add value to me? So there is a huge amount of questioning that takes place. Very healthy. This is also healthy that unless your people at the ground who want to take the ownership understand how it is going to help you to make sure you go to the next level of business level, it doesn't make a difference, and it is not sustainable. So you have to make this transformation journey sustainable. You need to make the ownership at the production manager level, then get into the shift engineer level. Yeah. Are they buying into it? What are their concerns? What are their fears, saying that after investing into this, we are not going to get this any particular this thing. So we have done workshops with the people who have supplied these digital technologies. We have done workshops with interface workshops with the ground, the technical people who are the panel operators and the shifting charges. Now they are saying, I have a DCS, already DCS is giving me. What is that you are going to give me separate? I have a DCS panel. I am operating my plant with DCS. So what kind of a change that you are going to bring? So there is a huge amount of interaction which has happened between the digital technology suppliers and the production people, understanding each other, how this technology is going to change the landscape, how remotely I can also operate this plant, not only here, how remotely I can give my analytical inputs, the specialists, the experts who are there, whom I have to call on telephone. I will download the information from DCS, then I will upload this information for the expert to give me advice on that. So this is an online activity today. So how these advantages, how we are saving time to take decision-making processes much faster, how we are gaining in what small things we are gaining in this. We are trying to ask them to capture them and showcase them. Tell them that you represent it. So I encourage my production manager to present to me. I encourage my panel officer to present to me. Is there a small improvement which you want to say by way of this activity which we have done? So that is now slowly bringing in the transformation culture into the people, understanding this whole process, that what is it that we are going to do to get to the next level. This
very well said. Very well said.
Very, very small steps in this. There's a huge amount of activity that needs to be done.
No. I think you've clearly articulated that focus needs to be on every persona. You started off with production managers, but going down to supervisor levels and so forth. But for every role and for every individual, there needs to be a focus. Well, we are running out of time, but Pushkar, I'm going to bring one last question to you. I want to explore along with you. How much do you think? How deep can you take digitization? In the chemical, manufacturing context, to what level do you think we can drive digitization? What's your point of view on that?
I think the depth and the breadth are both equally important. But I mean, like most processes, and as my fellow colleague said, it's not only about doing an ERP, it's about taking even the rest of the world, including the factories, to a digital enterprise world. But I wouldn't say you should swim deep waters, in the beginning. You get familiarized, get your people in first. That strategy is very important before you talk about depth and breadth. Investments are not only about putting in money, putting in time is a critical aspect. And I think people, as he said, rightfully so, and I was feeling resonating whether we're working for the same company, though we haven't spoken, because I think it's a problem statement across the whether it's small, big or large. Everyone's saying, I don't have the time. Small companies will probably say, look, I don't even have time to make the production. So where am I going to? But I think it's more of investment of time. And the POCs that we've done, and this is not the first year that we've been doing it, have given the assurance, like pulling in data and integrating them with ERPs. We typically do the historians, but we can go beyond that. And the analytics layers, there's so much beautiful AI ML application portfolios today that are simple to use and easy for business to consume. It's only opening up the mindset. And once that opens and that extrapolates with breadth, whether it's in the health and safety, which we are now penetrating and making it enterprise level, as well as, and the good thing about maybe for us is some of these technologies come from adoptions in the rest of the world. Sometimes compliance forces you to come there, and that's probably also a good sign. But believe me, if you have a self-action and if you have PNL oriented approach, which is happening, you would, I would believe you could go, the sky's the limit to the depth and breadth. And you have heard of manless cars, so you can have even operations going without people, but it's more of safety and factors, because you can use your people more for analysis rather than just execution. That's the way I would visualize it for them.
That's very well put, Pushkar. Really appreciate it, and I think between both of you, we've covered a very wide range of topics. Wish I had more time, but it didn't feel like a half hour or more has already passed since we started. But just to wrap this up, excellent deliberations on the entire range of topics, from what it takes, the business impact that can be created through these technologies, the factors that you have to keep in mind as you go through this journey, and having a problem statement, as you put it, right? So having an outcome in mind and not just doing it just for the sake of it, all very, very important considerations. I can't thank both of you enough. I think your comments and your insights have set the stage very well for the session that's to follow now, and immediately following us is going to be an introduction to the digital thread, right? That Mr. Biju Jatindran from Calypso is going to be walking us through. And I think some of these comments, Pushkar, that you made, have actually created a very nice segue into that. So with that, I'll bring our discussion, this panel, to a close. Appreciate the insights. Thank you so much, panelists. Thank you.
Thank you very much. Thank you very much. we still have time, and we have a question for Mr. D.S. Ravindra Raju,
Sure.
which is asked from Professor Rakesh Patak. He wanted to ask, majority of human resource in chemical industry has reached a certain age. Do you see challenge in assimilating these technology which we are talking about while implementing the technologies in your organization?
So yes, the question is very relevant, and I would tell him that those of the companies which are more than 40 years old, especially with unionized category, especially with the unionized category employees, we will have a little more challenge. But once they realize the importance of this change as part of the collective bargaining process, as we move along, I think the entire industry will change and embrace this one. Yes, the challenge is there. There should be a resolve from the top, and we should see that how we can put the transformation change process from the bottom. And how do we drive it? How do we motivate it with the proper motivational tools which we have to make sure it is linked to performance, whatever is the outcomes which are coming in. There are various tools where various companies can operate with various tools. But yes, challenge is there, but the solutions are also there. So that's my answer to it. We can do it, and we are doing it.
Sure.
Mr. Shawnee, if you want to add from your technology perspective and your experience perspective, you want to add to it?
No, I think this the considerations on managing this change and reskilling people. It's a very, very important aspect, right? And there are a lot of technologies that are not only available but are being increasingly utilized in the industrial setting, which make it much more easier for people who are adept at the legacy way of doing things, for them to pass along their knowledge to people who may not have those skills, or for those people to be cross trained on newer skills, right? How do you go about doing that? Augmented reality is actually making it a lot more easier, and such solutions and such use cases are actually being quite widely embraced. COVID times have actually accelerated that, because you certainly had paucity of people available, right? So yeah, I think that would be another one insight from my side.
One thing I can add on is, Hafiz, that we can do competency mapping. We have to relook at the competency mapping of these positions in future as we go along. See, the organizations like us, we have to see the JDs and the competency mapping as we go along. And based on the JDs and competency mapping, the existing people have to be skilled to meet that competency mapping. And we have a measure. Say the competency mapping is at the level of 2, then you go to level of 3 minimum out of a level of 5. So like you need to move up the competency mapping level as depending on the position to position. How do you do this competency mapping in these areas? So this exercise can be taken up by the respective HR departments and the operations and the production departments to make sure the whole organization is moving towards this goal.
Well said. And using some of these newer paradigms to ensure that the competency gaps are very quickly addressed.
Yes.
That's good. Hafiz, is there another question? And do we
Yeah,
have?
yeah. We have another question for Pushkar. Mr. Rege. So Shirish Jain wanted to ask with you, how can we conduct FAT for control system remotely in this COVID times? And he also wanted to ask from a hardware panel writing, software test, etc.
These are factory acceptance tests. So, which would typically require engineers to fly down to a vendor's premises.
The DCS systems, etc., which have to be done, FATs have to be done.
Correct.
First of all, probably, I don't think that layer is open for somebody to do it remotely. If you have done that, then obviously you can have security layers and you can have VPN accesses, but I wouldn't recommend that in a 2-minute conversation. It's a longer topic.
Correct.
So,
but
it is more experts that we got to.
Correct. But Pushkar, COVID forced people to adapt, and this was one of the adaptations, which was done. I'm certainly aware because people just couldn't travel, and we've had instances where they've utilized technologies, which allow you to remotely collaborate, not just human to human as we are doing virtually, right? We are as if we are face to face, but making sure that you have a piece of equipment or panel, being remotely, accessed by a bunch of experts. So you could two humans sitting at two different locations collaborating on a piece of equipment. Technology is there to support that now. But yeah, I mean the security considerations that Pushkar alluded to, certainly do need to be taken care of. Yeah, but it's very much practical, and I'm aware of several instances, including in our own factories, where we've supported this. So we'll be happy to share more details, Hafiz, through you. I'm sure there's some white papers that could be circulated.
Perfect. Thank you very much. I'm sure we can reach out to the person and share more insight to him.
Sure.
I think thank you very much. To all the panel members. I think we have the time was very short. For to get the experience. What you have. We will. I'm sure we'll create more platforms such. But we with this, I know would like to end the panel one, and would like to thank everyone. And with this, I would like to invite Biju, who's the senior manager with Clapso, Rockwell Automation Company, to do a small presentation on unlocking with digital potential. Biju, over to you.
My name is Biju Jatindran, and I'm a senior manager with Calypso, a Rockwell Automation company. My presentation today covers how companies are unlocking their digital potential. This is just a fancy title to describe how companies are actually taking advantage of digital process and capabilities in the industry today to derive meaningful results in their day-to-day operations. Before we go any further, it is important to first define a few critical terms that we will use throughout this presentation. The first term is the digital thread. The digital thread is a seamless flow of data that connects business processes across the value chain to deliver measurable benefits to the organization, such as reduction in operational costs and unplanned downtimes, a measurable increase in factory output and throughput, increases in overall equipment effectiveness, greater workforce and labor productivity, and so on. In other words, imagine the vast amounts of data associated or produced at each stage of a product, from design, sourcing, testing, and production to distribution, point of sale, and use. Now imagine this data existing as a single version of the truth and flowing consistently across various business functions and processes, always evolving with new and more relevant information, but never getting lost or regenerated, thereby resulting in increased collaboration and alignment across the organization. The digital thread describes that seamless flow of data, and companies today are constantly looking at ways to enable this digital thread and bring it to life. If we can imagine a product lifecycle from discover, create, make, and sell, the individual activities across the value chain, represented as nonlinear nodes in this diagram, can be supported by a combination of digital tools that allow for different competitive capabilities. For example, we utilize data science and advanced analytics to drive predictive and prescriptive insights for new product discovery and development, increasing the ability for organizations to proactively make decisions. We can also blend digital and physical experiences to gain additional insight in the product development process and increase collaboration and alignment among different business functions. Here's where the concept of a digital twin comes into play. The digital twin is essentially a digital representation of the physical entity or system across its life cycle using comprehensive data, analytics, simulations, and emulations. As we move across the value chain from create to make, this is where the designed product is now being manufactured. Companies are reaping the benefits of intelligent automation in the plants through the use of control systems and connected machines. As we move further within operations and field services, for example, the use of extended reality solutions help operators and maintenance engineers enhance their situational awareness. They are able to augment reality or operate in a virtual world through the use of wearable devices and associated technology platforms and drive remote service and equipment maintenance. They're able to virtually collaborate with the different teams and improve plant floor assembly and operations. And finally, the digital thread ensures that the seamless flow of data bridges traditional boundaries through the use of smart connected products and services. So what does this really look like in the chemical industry in terms of the key digital use cases that companies are investigating? That they're investigating, either putting in place right now, or in several cases have already put in place and are deriving measurable benefits from. We broadly see around 6 buckets of core capabilities or technologies. The first bucket is artificial intelligence. Now, the use of advanced analytics through machine learning has increased substantially in the past few years. For example, developing, training, and running mathematical models to help predict and or prescribe formulas and taxonomies based on previous target parameters and selections, and then having these models continuously learn and improve the output. Also, as chemical compounds are being developed, we can use models to conduct analyses for key performance indicators such as toxicity, exposure, and environmental impact. Now, this brings about tremendous efficiencies in the quality assurance, compliance, and regulatory approval processes that oftentimes are major sources of delay in development and operations. The second bucket is extended reality. This comprises the use of augmented reality and virtual reality solutions to allow operators to conduct remote service and equipment maintenance, especially in dangerous or hazardous environments or while dealing with toxic chemical substances. In the current pandemic era, this capability has come more into the forefront as physical interactions have become increasingly limited. Additionally, these technologies help operators and personnel collaborate much better. Imagine a scenario where a field engineer and a remote maintenance technician located miles apart have the ability to virtually view and intelligently interact with a specific piece of machinery that requires service. That kind of collaboration, that kind of interaction significantly reduces downtime, significantly reduces rework, and just makes the entire process go smoother and more efficiently. Additionally, we also see AR and VR being used increasingly to train personnel and ramp them up in a fraction of the time compared to traditional methods. The next bucket, product lifecycle management, focuses on the set of processes and technologies to manage key product data across the value chain. It describes the structured set and hierarchy of specifications, for example, that describe what the chemical product is made up of and how it needs to be manufactured. This data is change controlled, right, which is a term for indicating that any changes to the core information beyond a certain point in the workflow requires cross-functional review and approval. It is critical to ensure repeatability, efficiency, and quality in manufacturing operations. The next bucket is a combination of different things. It's modeling, simulation, and emulation. We've seen examples in some of the more advanced organizations where they're using things like automated cloud laboratories for the development of synthetic compounds. These are a line of robots as you would have in an assembly floor or a plant floor, where these machines are essentially focused on pulling together the latest chemical compounds, reagents, and other substances, all in the cloud. Increasingly, we use data science for modeling sensory and performance characteristics, and even the molecular properties of the chemical substance. Digital twins are the next category. As I mentioned earlier in the presentation, this refers to the digital representation of a physical asset using technology platforms to mimic the geometric, polygonal, and compositional models of actually the physical asset. The digital twin also digitally represents physical processes and dynamics such as heat exchange, pressure, vibrations, and fluid dynamics, and so on. Emulations of PLC logic and animation of physical processes, which are used to digitally then create manufacturing automation processes. The twin also is a digital representation of the human interface to a product, including maintenance, operations, and training procedures. And then it also provides a digital characterization of the data, measurements, sensor readings, and telematics of a manufacturing asset or process. Finally, we also have what we call connected operations or smart connected operations, which is basically the concept of a smart connected ecosystem of equipment and assets, gathering data, and then the ability to interrogate that data to drive valuable insight into operations. Now, this includes capabilities, for example, like dashboarding and analytics for overall equipment effectiveness, OEE. It's a key capability for several of our clients, helping them understand the availability, performance, and quality of their assets and manufacturing operations. Oftentimes, we see a lot of manual intervention on the factory floor, right? Operators and line managers either measuring and writing down values on a sheet of paper to be stuck on a board somewhere. Someone might read it, someone might not. Or statically running reports on a tool several minutes or hours or even days after the completion of a specific process. Today, there are tools and architectures that we can leverage that can report on key performance indicators in real time, allowing plant managers, line operators, etc., to take decisions and make changes faster and improve overall OEE and workforce productivity. The next two slides illustrate the applicability of some of the use cases that I covered across the different segments of the chemical industry, whether you're looking at commodities, specialty chemicals, fine chemicals, or plastics. Our analysis indicates that while specifics of the use case or the scenario may vary by company, product, and manufacturing process, the underlying methodology, approach, platforms, and capabilities are largely applicable across the board. So I'm going to take an example here, of OEE dashboarding and analytics, and let's just talk about that real quick. The specific KPIs and the metrics may differ by process or equipment in a commodity chemicals plant versus a fine chemicals manufacturer. But the methodology and the architecture of extracting information from the underlying PLCs, interrogating that data, and visualizing it in performance dashboards is a common goal to get real-time visibility into operations data to drive OEE improvements. The secret sauce and the competitive advantage that Calypso and Rockwell bring to the table, of course, is being able to utilize leading practices and tools in connectivity platforms, data models, monitoring algorithms, benchmarking engines, and industry-leading dashboard templates gathered over many different experiences across the industry. So now that we have looked at the story of the digital thread, the universe of applicable use cases, and the key steps in beginning to unlock your digital potential, the next question really is, how do we enable or implement these digital capabilities to derive tangible business benefit? Our suggested approach, and one that we see works very well in the industry, is the concept of what we call the minimum viable product, or the MVP. Now, before we get to the definition of the MVP, it is important to understand certain key truths when it comes to enabling digital capabilities in the organization, or even embarking on a Industry 4.0 smart manufacturing digital transformation type of initiative. What we found is that solutions fail when they don't achieve immediate business impact. Business impact typically requires the implementation or the enablement of comprehensive capabilities. And therefore, what we found is that foundational approaches really tend to fail, don't really work. For example, to give you a very small example of what of what this means, as an example, organizations focus for months on things like data cleanup and synchronization efforts with a view to eventually having clean data to run analytics on and derive insights from. But once the time organizations spend all that effort and money on doing that, there is either organizational exhaustion or loss of sponsorship, since the immediate business benefit is not apparent or demonstrable. Alternatively, what we suggest is to apply a comprehensive capability with a narrow application focus. And here's where the minimum viable product, or the MVP, comes in. Think of the MVP as a proof of value that builds out a specific business critical use case that also includes the build out of the essential production ready foundational and infrastructure components needed to support that use case. Now, in setting it up this way, the MVP approach allows for quick scaling of the solution to production. This approach differs from your typical proof of concept approaches, as it is focused on demonstrating the achievement of business value and minimizing any throwaway infrastructure components, rather than demonstrating a set of technical capabilities in a standalone manner which is typically what the proof of concept seeks out to do. By doing this and by focusing on value and measurable business benefit value, you are always focused on the priority use cases. You deploy a full stack of capabilities, and then you add value first, followed by scale. And once you establish value using a minimum viable product, the scaling of that use case, either to additional locations within the same facility, additional lines, or even scaling up to additional use cases, becomes that much more efficient and easy. In conclusion, organizations today are leveraging digital tools and technologies to enable the digital thread and bring to life of what we call the connected enterprise. In the chemicals industry, companies can embark on this journey by identifying the key use cases that result in measurable business benefits, and then utilizing a minimum viable product approach to quickly and comprehensively prove out their hypotheses and scale that proof of value pretty quickly across the enterprise to achieve true and lasting digital transformation. With that, I'd like to thank you for your time today. I hope the presentation was useful to you, and let's open it up for questions.
We have a poll. Before that, if I can ask you one question, that chemical firm have been doing modeling and simulation, applying analysis for a long time. What's different now in this current situation?
Yeah, no, that's a great question, Hafiz. And we get asked that quite a lot by by our clients who've essentially been doing a lot of modeling and simulation and analysis over many years, many decades, in fact. All I want to say is, today we have the tools and the technologies and the capabilities to be able to do that, really efficiently, really quickly, when you look at sort of how the industry has evolved, there is increased connectivity, right? There is increased computing power, cloud and data storage capabilities, and just an evolution of capabilities around data science and analytics, right? What we used to do before, or what we've seen companies do before, is essentially take up all of that data, do a descriptive and diagnostic analysis of data retroactively. Today, we have the ability to actually put mathematical models and algorithms in place that are predicting outcomes or even prescribing outcomes on those vast amounts of data. So yes, the fundamental concepts still remain the same, but today, with the availability of high compute power and the technology to support that, right, you are able to just grow by leaps and bounds.
Perfect. Biju, we also have a lot of questions, so we're going to take it offline and share that so that you can share your perspective. We have a quick poll. So Rohan, I would request if you can start the poll. Requesting everyone to please respond to it. People who respond to will respond to it will get a 1-year free subscription of Manufacturing Today India magazine. So the first question is, have you implemented any of the following broad digital capabilities in your organization? So we take 30 seconds, then we show the results. So can we start the second? Can we show the second question? Apart from that, if you have any more questions, do drop in Q&A box. Do you have a mandate plan strategy for digitalizing your factory? I'm sure the answer will be yes in current situation. We have 3 more questions. How would you describe your digital maturity? It was a tough one. Can we have the answers? Results? Please rank these capabilities in order of maximum priority for you. In your current role, what is the maximum priority you think amongst the list? This is the last one that people do answer this. What are some of the biggest challenges in starting adopting digital? Multiple choice, you can choose. Okay. Thank you very much for participating. With this, let's start with another interesting panel discussion on a topic of stimulating a new wave of innovation through collaborative ecosystem. We have Mr. Ashok Muthuswamy. He's AVP and plant head, Silica Tata Chemicals. We have with us Mr. Sharad Joshi, head digitalization, smart manufacturing Southeast Asia, Australia, and New Zealand. We have Mr. Ashok Malhotra. He is the plant head SRF Limited. And we also have Mr. Arvind Kakru, country head end user and EPC business from Rockwell Automation, who will be also the moderator of the panel. Over to you, Arvind.
Thank you, Hafiz. And a very good afternoon to all of you. And it gives me great pleasure to host all the three esteemed panelists who you just introduced and who will participate in the discussion of the topic. They are veterans of this industry and have deep domain expertise in both chemical and digital industry, which is at core of what we're going to be talking about today. So from novel process technologies today to sustainable plastics, the chemical industry is in midst of a profound change. Digital transformation in chemicals is presenting immense and largely unexplored new potential to not only increase efficiencies, but to help companies design novel products and processes. Advanced in networks and sensors, data availability, processing, engineering, material technologies, they all hold very considerable potential for expanding efficiency and productivity in chemical industry. That means digital transformation in chemicals presents even more significant opportunity to increase innovation in products and solutions. We'll today try to evaluate our options on taking the full advantage of digital transformation, how an enterprise-wide digital strategy is often needed, which percolates down to customizable parts suiting the needs of individual business units, right? And this is how digital strategy ties into the digital maturity model that we talked about in the beginning, where organization is right now and where it aspires to be once the digital transformation is done. There's a lot of excitement about the potential of digital and chemicals, just as there is about every digital initiative across society in general. We believe that digital will have significant impact on many areas of chemical industries across value chains, productivity, innovation, and new channels to market. Companies nowadays can use advanced analytics to extract management relevant information from a large amount of unstructured data that they generate. This information can be used to improve the plant's operations and make them better informed and help in speedy decision making, which can be cutting across all the businesses. Companies can turn more towards some new productive models, to perform the simulations, what-if simulations based on data to achieve the strategic agility and operational excellence. So in the wider world, the chemical industry is essential supplier to myriad other industries. And so these industries are being changed in digital is in turn translating to opportunities and challenges for the chemical companies. A study done by Accenture indicates that 55% of chemical companies that invested in digitalization reported profit increases of 5 to 20%, while about 25% of the companies saw profits greater than 20%. So with this brief, we can start the conversation with the panel and industry experts who will try to address some of these points today. I'll start with Mr. Ashok Muthuswamy, who has got considerable amount of experience across different functions, manufacturing, operations, SCM, business excellence, etc. So, Mr. Muthuswamy, the question for you, like you have a very wide experience across various functions, and as plant head, how do you see the digital transformation for the future, especially with respect to Tata Chemicals?
Sure, great question. So let me just take a few seconds to very quickly introduce Tata Chemicals. And I will quickly come to this point. So Tata Chemicals is the world's third largest producer of soda ash. And we also have other products, including salt, chlorine, bromine, specialty chemicals, and nutraceuticals. So that's a quick intro about Tata Chemicals. Having said that, how do I look at digital transformation? See, first and foremost, you should never lose the sight of basics. The basic is we need to develop product that market wants in a much shorter lead time with perfect quality, while ensuring safety of all personnel and meet and exceed regulatory norm and deliver all these at a very, very optimized cost. So that is the basic, no matter whether you're doing it digitally or any other means. But what digital strategy really does is it provides you wonderful toolkits to achieve all these lofty targets, sometimes they are not, they don't coincide. Sometimes, they don't meet each other, some of these requirements. And that's what a digital strategy and digital toolkit does a whole lot of help in addressing these aspects. So once you exactly know what customer wants, you need to have a product design. And that product design should be seamlessly transitioned into production processes. And here is where also a digital strategy will come extremely handy. For example, error-proof manufacturing process, which is absolutely essential. And that will require repeatability, which can only be achieved by SCADA, DCS, and other what we today call as Industry 4.0 concepts, such as process real-time analytics, dynamic SOPs, automated course correction, all these things. The digital tools and computing advancements make all these things possible. And then we also generate reams of data. It gets into terabytes of data. Earlier, it all used to be in a silo and it used to be destroyed. But now you have all these excellent data sets, which you can use to develop predictive analytics. See, for example, in my organization, what we are doing is we are developing a bunch of calculators. What does it mean is if you want a particular grade of end product, what are all the process parameters that will help you accomplish this end product? So it's exactly a mathematical equation. Y is a function of x, x1, x2, x3. And for a good time, we were dependent on empirical knowledge as well as functional knowledge to develop that equation. More of causation. But these analytics really helps us on the correlation side. Even I think so. One of the earlier question was, what are we doing now different than what we did before? Earlier, we didn't have all these data, like the big data that we have right now. And number two is we didn't have the computing power or even the inclination to analyze all the data. So that's where all these, the new advancement greatly support manufacturing processes. And similarly, maintenance functions. Nowadays, it's more and more common to see a lot of predictive analytics and AI in maintenance so that we can understand where the equipment is heading. Instead of just doing a preventive maintenance where you just replace a bearing, whether or not it is good or bad, with predictive maintenance, you exactly know when to replace a particular bearing or a shaft, and you also know exactly at what time you're going to replace it, so that you don't incur unnecessary maintenance expenditure, and you also don't unnecessarily incur downtime. So all these aspects, you have to see. I mean, sometimes these all could be silo. A proper digital strategy is to integrate all these aspects and see how you can leverage the best out of these.
Sure. Very well said, Mr. Muthuswamy. Thank you so much. Next question, Mr. Sharad Joshi of BSF. You handle geographies, in India, outside India as well, especially in Asia Pacific. So what is the extent of smart manufacturing or Industry 4.0 enabled at your locations, and how do you kind of see it evolving, in the future?
Yeah. So thank you. First of all, thanks for inviting me on the panel to put up my views on this subject. Thank you very much. So at BSF, I will say, we see that Industry 4.0, or we all call it now as a digitalization, is applicable across value chain. So you can't just put it into the box of manufacturing, but it also have application in business, in research and development, in supply chain, and definitely manufacturing, what we are talking about. If I have to speak about manufacturing plants, then I will summarize, or I will just divide it into different categories and the different solutions which we are implementing today. So I will say one is a connected workforce. This is one of the important area where we have all the solutions related to mobility, including operation round management or computerized maintenance management system, which are now brought into the tablets, whereby the operators in the field is able to take all the notes, recordings in the field using the tablets, which are part of our integrated augmented reality platform. We have wearable technologies like HoloLens, smart glasses, which are being used, and now in the current COVID situation, you can imagine the benefits it brings in. I will not just, discard here the application of drones, which is also one of the part of our mobility platform. Coming to other domain, which I will call it as analytical solutions, and which is used to improve productivity, reliability, and the predictive maintenance. So different solutions we have, as Mr. Ashok also mentioned, using all the data coming out of the process and using this data with the predictive analytic tool to identify the failures, probable failure, and take corrective steps. Another important aspect to it is about IoT sensors, having a wireless sensing now, the certain non-critical equipments where you really don't need a predictive or prescriptive analytics, and you can still go with the kind of measurements which are low cost solutions and as well as are able to identify probable failures. Engineering management or change management in the plant, chemical plants, is one of the important aspects. And how we manage that using digital twins, that is a complete digital replica of the plant, providing all the engineering information to all our engineering staff, all our operation staff at a right point of time, is also one of the important aspects. And that is driving us a success towards engineering, which will be much faster, reducing the turnaround time, improving the plant availability. Coming to another important area, and I would say one of the most important area for all of us today, is a EHS. And smart EHS, environment health safety platform, is also one of the area which we are working in the region, and which include e-permitting, like digital permits on paper. Instead of paper, we are moving it to the digital permit, which are much more comprehensive, include all the required information. The job safety analysis can be done online. And apart from that, the isolation management is also one of the integrated part of e-permit process. There are certain additional aspects to this, which include incidents management, reporting onto the portal, and all this is being moved into the digitalized domain over a period of time. Another important aspect in terms of operation, I would say, is connecting the plants. We call it as a vertical integration. Sometimes people call MES, but it is more of connecting, starting from warehouse, raw material, up to finished good, and entire process is being connected. The visibility of the raw material availability, visibility of the incoming material is also being increased, and effective supply chain management is resulting into this. And another important aspect is the transferring the final information back to the customer, made it available, making the product available at right point of time, is also one of the important aspect of this, connecting entire assets using vertical integration. So I will say that this journey of digitalization is never ending, and new application and use cases are being identified, and we see a lot of potential, particularly taking this journey into the chemical industry. Yeah, thank you. Over to you.
I agree with you, Mr. Joshi. Yeah. So I think you got some interesting perspectives on use of technology and vertical end-to-end integration. Thank you so much for your views. Mr. Malhotra from SRF, how do you look at some of the challenges that are there today in the industry, which are like resource optimizations and asset utilizations? You have any viewpoint there or any experiences you can share with us?
First of all, I'll start thanking to the manufacturing today for giving a wonderful opportunity to share my views and be a part of this panel. This thing is basically starting with customer. Customer nowadays, all customers are wanting a differentiated product. Gone are the days I produce one product and it will be absorbed at multiple customers. Everybody want customization. Today, if an opportunity is given to a customer to customize your mobile, you will like to have your own button and photographs on that. You will not allow a simple product. I think days are not far off when you start getting these kind of options also. So based on that, what happens? Each product is different. Each customer is different. So this is putting more challenge to the team in terms of dynamic planning. Now it's not that the customer has ordered and you are producing, then immediate change is required. At that time, what happens? The dynamic planning comes into picture. So you need 24/7 availability of your maintenance as well as planning team, virtually or physically present in the company. Cross challenge there is coming. This new generation, which is coming as engineers now, expertise engineers who supposed to be in the factory 24/7. They don't want to be there in 24/7 because they have coming and joining the industry, they don't want to do the shifts. Their outlook is that we want to be in general shift, and we in the evening we want to be in our houses. They want 5-day week also. So this is a posting a challenge to continuous using the asset as well as producing for the differentiated product. So what happens in this case? We have been taking the help of augmenting reality, where remote sport is coming a big handy thing to us. Like we have got that virtual glasses, wearing that and showing to them. That has started helping us. The second part which happens is comfort in the environment. Nowadays, people are not used to that old kind of thing that your machines may be making the noise. There may be noise pollution, there may be air pollution, temperature. The demand on that side is very, very high. And on top of this, unions come into picture to enhance that further. So we have to be very careful. Though we have selected the best machines, whatever with us, but the fast technology changing. Now the machines are being more noiseless, like generators are noiseless. So machine, the demand is increasing, but it's not possible for us to change the machine very frequently. So that is also a contradictory thing which is coming to the asset utilization at that time. Then finally, the markets are highly unpredictable nowadays. So you cannot think of what is going to happen next tomorrow. So produce and sell or take an order. Customer don't want to give you an order for next tomorrow. They say, I will inform you and you have to start production immediately. That is his expectation. So that is also keeping this. And above all, the major challenge is the asset utilization is coming very short PDCA cycle. We are still using that plan, check, do, act, but now it has to be very, very short. Your engineer on the shop floor has to take a decision. He cannot wait for his superior to convey him the decision. So to working in the short PDCA cycle is also a challenge. People have to learn how to take decision and how to dynamically change. He's doing something. When the situation changes very fast, then his planning has to change, his action has to change, his decision has to change accordingly. And the information flow is so quick that you cannot wait for the next day to come and take a decision on that. Gone are the days that we used to have a maintenance, a production planning meeting, decide and then go home. And then till next month or till next week, we need not to do anything. The machines will be running as per the schedule. The schedules have gone now. The schedules are changing on daily basis because customer is also following the same principle. They are also working on zero inventory basis. Now the other challenge is coming in terms of our manual process. So wherever the manual process is there, the interventions are more. The man is working elsewhere, the machine is idle for one part of man on the other side. So more and more automation, if we can put into the picture, more and more robotics come into the picture, then this manual dependency will be coming down. And the major one more challenge what I am seeing is the resource allocation by the people. So when the people come to the shift, you allocate them certain machines. But I am finding that fast changing, we need to change that machine in between the shift also. For that one, what we need a flexible manpower. Today is working in a certain kind of machine. Tomorrow I may require, or in the mid of the shift, I may tell him to leave this machine. Please go on to that machine because it becomes a priority now. But the thing is, this changes what we want from the manpower, from the human assets. They are not flexible or resilient like that. Reason being guided by unions. So union is posing a threat into that. Then comes we now how we have encountered some of them. When I talked to my production manager, I started telling him, don't give me that this machine has produced how much. You tell me this has not produced this much, why? So give the account of unproductive time. Don't give me the account of productive time. Efficiency, I don't need to say, you are telling me my machine is at 85 efficiency. I'm not interested in that. Tell me the remaining 15% where it has gone, whether it was avoidable or whether some multitasking could have been done. So let's talk about that. This 85 has happened. There's no need to monitor this 85. My main stress is on the remaining 15% where I'm losing. So with that kind of thing, we are able to now utilize the asset to a great extent.
Those are very, very good insights and very valuable. Thank you so much for sharing them with us. I'll go back again to Mr. Muthuswamy. I just wanted to know your views and how you kind of plan to combat your biggest challenges, which could be related to productivity, again, asset utilization, and to a large extent, process safety.
Sure. So just quickly touching on what I mentioned earlier. So first is the customer need, where you need to have a product that customer want. And while developing the product, you have to ensure safety, quality, and productivity. And digital enablers come very, very handy. So what we do, we look at a lot of interlocks in our processes to ensure safety for our people and assets, and also have a lot of smart OKs. So those, these interventions help us ensure safety. And similarly, quality, what we try to do is ensure that customer get the product that they want. And the key is, how do you have your manufacturing processes tuned to deliver what customer wants? And this is where predictive analytics really come handy. So it helps you identify the right process parameters so that you can deliver the perfect product parameter. And similarly, automated and streamlined manufacturing processes will also ensure productivity and ensure error-proof process. So all these things, like I said, it's a virtuous cycle. One will leverage on the other, and so on and so forth. And eventually, you get a very virtuous cycle going on. And I also mentioned about all these calculators that we use, where we have around like 30 to 40 process parameters. And all these are analyzed using analytics to find out the key process parameter and the setting of them, so that you get the best possible product outcome, whether it's in terms of product specification or yield or quality, and similarly while ensuring safety. And warning systems and other predictive analytics, all these helps you in several of these areas. All these challenges that you have, and there are all these digital enablers that help you address these challenges. So one of the key things, even in one of the surveys which I saw, is what is your holistic digital strategy? So while having all these things on silo, you will only get so much benefit. But if you could integrate all these pillars of product design, safety, manufacturing, and maintenance into an integrated digital and collaborative ecosystem, that's where you get the biggest bang for the buck. And since these pillars are digital, they are also very conducive for being integrated and creating such a seamless collaborative system. So this is what we need to do. We are somewhere in the journey in between. The key challenge would be to ensure that the buy-in is there, and you also need to, constantly you need to show a proof of concept. Nobody is going to write a blank check if you are not, if you have a very, very long-term vision where you can't show anything in the short term. So it will be a lot of proof of concepts where, all these things you are showing some deliverables on the way. While you keep the long term, you also need to ensure short term. So that would be how we address the challenge.
All right. All right. Thank you so much for your insights. Mr. Joshi, since you have a very close connection with digitalization in your organization, how do you see or ensure safety and security, which is an aspect, that I want to bring about now, especially with respect to the digital initiatives and the cyber security piece of it?
Yeah. So definitely, while we use any digital technology and tool, it will bring up certain, the safety or the security measures risk which you brought it in. But before I address this question, I would like to put up other perspective to you. And it is, I don't see that the technology is only posing us the threat in terms of safety or security. Instead, technology is also helping us in terms of improving safety and security. And definitely you have seen in my last answer when I mentioned about use of e-permitting or solutions like safety EHS improvement. I would like to bring up two use cases here which help us in terms of improving safety. One is the use of drone for confined space entry. And you can just imagine the kind of risk which is involved in industry in a confined space entry. And when you are using drone, you are minimizing the entry of the personnel in the confined space for inspection. Another simple example being, we can take an example of inspection of chimney where drone can be used. So you can bring the kind of a reduction in the risk which involve with building scaffolding or, the working at heights. Another simple tool which we are right now working on or implementing is about contact tracing using RFID. So with the COVID situation, we have this kind of very specific need where people have to work with certain social distancing. And when they come closer to each other, and we found some case positive in coming days, we have to take corrective step, who was in contact with that. And this kind of actions, you can use technologies like RFID or like I would say video analytics to identify such kind of cases. So I would say this kind of digital tool are really adding a lot of value in terms of improving our safety, improving security. But while we use this kind of tool, definitely it brings up certain level of risk, carry a risk, and what we need to do is carry out the risk assessment and cover the risk mitigation, including some of the operational measures as deemed necessary during the execution. If it comes to the cybersecurity measure, I will say incidents are becoming cybersecurity is becoming one of the most important business risks globally nowadays. And it is our mission to protect our groups against cyber threats, to secure the digital journey in a sustainable way. By supporting our customer, our stakeholders, it is our goal to enable and support the business professionally and empowering our workforce. So they are not afraid of using this technology. And that is something which is important, to take that fear of cybersecurity, fear of safety, taking out from their mind so that they can use these technologies freely. And that's what exactly organization is supposed to do. And we are doing that taking out this risk by implementing certain measures. Training of the people is also one of the important aspects, making them aware of what kind of risk is involved. Another important aspect, bringing some security check measures while they work on the different technologies. So these are all measures which really help to take this kind of fear out, so that the end users, the operation staff, the engineering staff can freely use this technology. So I will put it in that perspective. Thank you.
Absolutely. Okay. Mr. Malhotra, we have one last question for you. You look after the whole operations and plant, so how are you looking at the digital transformation for future, from where you are right now and where you want to aspire to be?
We have gone quite few away. We have started, actually what we did, we started other way around. We started with this automation of our office moving, whatever it was. So in that one, what was the items, everything we have taken and then gone to the next level. We have gone to that way, onto the opposite side we have gone. So then we have gone for this 24/7 augmented reality sport, which is under development in our office going on. Then we have taken the early warning system, which is infancy stage. It has not matured, is infancy stage, which is being done. Then online environment monitoring is there, which is our air and this all is getting this one. And then we have done now all material handling, wherever the bulk handling is coming, like raw material or where is the packed material. So all has been shifted to automation. Now this is being done by robots, not by men. So this change we did, sir.
Sure. Thank you so much. I think very interesting perspectives and some of the like emerging technologies you talked about. Maybe we'll call it the connected chemical plant, as we call in Rockwell terminology. I think you addressed all of you and talking about people, processes, technologies, and a lot of insights into where you are, what you're doing, and how do you kind of address some of these things which are related to asset utilization, operation flexibility, safety, security, compliance, and improving the overall operations. I think we also learned about the tremendous user experience using analytics. We talked about talent, people, workforce capabilities. I think very intelligent kind of use and leveraging of cognitive tools like AR and VR and artificial intelligence and drones we talked about, and to some extent maybe RPA as well. In future, we looked at asset reliability, performance, etc. So I think very useful session. I would like to thank you all for your valuable insights. We'll now be moving over to our next topic, which is the connected chemical plant with plant PX 5.0. This would be delivered by Mr. Sandeep Redkar of Rockwell Automation. And after that session, immediately we'll be walking you through the connected chemical in operations at our virtual digital transformation center. So thank you so much, and over to you, Sandeep.
Thank you very much. Before that, we have one question from Mr. Kumar Iyer.
Sure.
Yeah, he wanted to ask to Mr. Sharath if you can take that. What digitalization project you have implemented in your organization from maintenance perspective, and since when and what is your experience ROI after implementation? It's
Okay. So was it a question for me, right?
yeah, for you and for Mr. Ashok Muthuswamy, if you can both share your perspective.
Yeah, Mr. Muthuswamy, you want to go first?
He's on mute actually. If you can start, if you want to add to it.
Yeah, so it was more in terms of the maintenance, right? The use cases in terms of the maintenance. Yeah, so there are several and different use cases, because if you look into the, we being into the specialty chemicals, different use cases are being turned up, or rather I would say the different plants have a different use cases, and this is being varying. So one of important aspect in terms of the maintenance, what we brought in is about the ORM, where operator round management, creating notifications through the field itself, and the entire material visibility. So more of material availability in the store, the technical material management availability onto mobile. So these are kind of applications which are making our maintenance team readily available with all the information. Another important aspect, we are also now working on some of the pilots whereby we are trying to bring all the operation and maintenance information onto the tablet. So providing access of the information in the field. So when maintenance team is working in the field, they are able to get all the required engineering documentation in the field itself, so that the corrective steps can be faster. So instead of referring to different documents, so it is more of maintaining single source of truth for all engineering and maintenance information, and make that information available to the plant maintenance team. Another important aspect while doing, and we call it because engineering and maintenance much closely associated with each other, the digital plant aspect of us is bringing in kind of faster engineering execution. So we are maintaining all the 3D models of the plant and PNIDs in up to date, and which are being used for the engineering changes in the field. And that is really adding a lot of value to us. Definitely, this is kind of a application which goes with the big kind of plants. Another aspect which kind of doing a maintenance and inspection activities, we have started using drone application for the inspection. As I mentioned, confined space entry is one of it. Another is inspecting a big tanks. We are started using the drone. How can we effectively utilize it? Coming to your second question on the ROI. So ROI, yes, it is one of the important aspect. And one aspect what we always look into is we don't want to do digitalization for sake of digitalizing it. It has to have a solid business case behind it. And that is one of aspect we always run into. So all these solutions are being explored into the level of ROI what it provides. And when you explore any new technology, you cannot go on day one with the ROI. So what the concept we follow is we try to run one pilots, and whereby with the pilots, we try to establish the use case, whether it is fully successful and adding value to one. Second, then what is the cost of implementation of this kind of technologies? And third, what kind of a risk or operative measures risk it brings, and then how to cover that risk. So these are three aspects being evaluated at the end of the pilot. And once pilot is successful, then it goes for a rollout. And at a rollout, we do a very detailed assessment of the business case. We also try to explore the alternate technologies, because a lot of time, once you do the pilot, and as digitalization is quite fast moving and very fast moving technology, always the new topics are coming in. And we try to explore the new topics and then try to re-emphasize or rebuild onto the business case. And still the business case or ROI found to be positive are taken forward for the rollout. So that's the approach. So just ROI, I will say that the first is exploration mode followed by ROI. And in pilot, definitely use case and ROIs are being looked into The first phase is to more look into the technology, and second phase is to go into the ROI topic. And that's the way it is being taken forward. Hope that address your question.
Yes, yes. So Mr. Muthuswamy, if you want to add to it.
No, nothing more to add. I think it was summarized perfectly well. So
Perfect. Thank you very much, to the entire panel. Thank you very much for sharing your insights. And with this, we move to our next. I would like to invite Mr. Sandeep Redkar, Manager Process Solution, Rockwell Automation India, to share his insight on the connected chemical with Plantex 5.0. Over to you, Sandeep.
Good afternoon, friends. My name is Sandeep Redkar, and today I'm going to talk to you about the concept of the connected chemical plant. I will also be talking to you about how this concept of connected chemical plant is realized with the PlantPX DCS. So let's look at overall scenario connected with the chemical industry in India. While the chemical industry is seeing a lot of tailwinds in terms of the inexpensive feedstock, as well as the high CAGR growth rate that is being projected for the industry, it also faces a number of headwinds. Some of the headwinds could come in from the point of view of environmental health and safety issues, which could be connected to environmental impact, process safety, cyber security, and sustainability of the plant. Then there are market pressures related to energy cost, to the global competitiveness, as well as the agility to be able to introduce new products into the market. Then there are concerns connected with aging assets and increasing cost of supporting those assets. Then there are ever-evolving legal, governance, and operational risk issues and regulations that have to be contended with. Further to that, there could be impact on account of changing workforce demographics. That is, old people, the subject matter experts, are leaving the organization, and new people coming in who need to be trained to the same level of competence as the people who have left this organization. All of these headwinds contribute in terms of impending the growth that the chemical industry is looking for. While headwinds and tailwinds are what they are, every chemical plant operator would require to focus on the business outcome that he wants to achieve. One business outcome would be related to operational insights, which will enable them to increase their yield, increase their throughput, increase the quality of their product, increase the energy efficiency of their or the productivity of their plant. While doing so, they would want to maintain the operations with reduced capital and reduce operational cost without increasing their risk exposure. They would like to optimize the facility operation while at the same time achieving a balanced asset utilization. While doing so, they will want to do efficient project implementation, at the same time reducing execution time and minimizing risk and cost of executing those projects. While operating their plant, they will want to maintain very high level of safety without impacting the productivity of the plant and rapidly keep their workers trained to improve the effectiveness while reducing the risk to their operations. We have a little while back listened to Biju talk about the concept of digital thread. And in the rest of the presentation, we are going to look at how the concept of connected chemical plant leads to the achievement of the benefits of the digital thread. So let's look at what a connected chemical plant means. The connected chemical plant is based on the Purdue model in which various layers of an automation system are identified. At the bottommost layer are the smart devices. The smart devices would be your measuring instruments for process variables. They could be your electrical components. They could be your rotating assets on which predictive maintenance is being employed. They could be your analyzers, and there could be any other kind of measurement device which is providing data about the plant operations to a higher level. Not only is the data important for operation of the plant, but the health about the data, as we call it the metadata, is also important for understanding how reliable that measurement is and in various different ways that it can be used to diagnose the real performance of the plant. Further to that, On the upper layer is the process control solution. This is the layer where all the mathematical and sequential logic is being executed so as to make right decisions about how to retain the plant in the most optimum zone of operation. Associated with this process solution is also the intelligent package power solution. Electricity is probably the largest energy source that is being consumed in the plant, and it is important that process control as well as electrical control is treated together as a part of the same system and are very closely interrelated to each other. This helps building a connected chemical plant in the true sense. Integration with third-party devices like, for example, laboratory information management system, SAP, or any other kind of ERP, and many other different kind of systems, data from which is relevant for bringing out the right context out of the data and using it to build a digital thread. Those kind of integrations are extremely important to build a good connected chemical plant. This may involve integration with manufacturing execution system as well as other tools such as augmented reality tools for improving workforce efficiency. All of these layers that we talked about, they lead to knowledge-driven operation, which is at the base of the concept of building a digital thread through your value chain. So the connected chemical plant is basically built on a secure infrastructure which connects all the intelligent assets within your plant operation so that they can share information with each other, and then they are supported by enabling technologies to build higher level of intelligence on top of that. Extended level of intelligence is used for visualization purposes, for control purposes, for analyzing the operation purpose in a very holistic real-time way so that appropriate decisions can be taken to operate the plant in the most appropriate manner, whether from a throughput point of view, quality point of view, or efficiency point of view. The infrastructure that we have seen in the earlier slide basically helps all relevant data and the metadata associated with that data, contextualize that data appropriately, aggregate that data, and then based on the aggregated data, deliver higher level insights to the right people at the right time so that they can base their decisions through that particular data. As I mentioned earlier, intelligent package power is important for building a connected chemical plant. Intelligent package power makes the process control system and the power system look like one system, commonly configured and engineered together, has direct visibility of data across both the system in a common interface to the user, and that helps in terms of improving the predictive maintenance and reducing downtime of the plant, as well as improving the efficiency of operation in terms of specific power consumption per unit produced from the plant. So there are lots of benefits of having an intelligent package power tightly integrated with the automation system. And then we come to the process control system. An integrated control solution will help you to get the most out of your process as well as equipment. This would lead to overall productivity improvement, at the same time reducing the maintenance cost and downtime. What would such a process control system consist of, or what are the capabilities that it should exhibit? A flexible continuous process control as well as a flexible batch process control that would enable making the right decisions at the right time, would be amenable to very simplified engineering, improvement in operations, reduce maintenance and downtime, should be safe and secure, and should be scalable. That is, it can be extended from a very small system to a very large system. PlantPX DCS is such a process control system. It is integrated in terms of power as well as process control. It provides a plant-wide control and optimization solution, which is scalable and modular. It is secure, but at the same time, it is information enabled so that information can be accessed from any component from within the system. And it employs a very flexible delivery and support model. Now let us look at PlantPX 5.0, which is the latest launch of this distributed control system. PlantPX 5.0 has a much reduced footprint, requires less hardware to do the same control application, has a very simplified engineering methodology which drives consistent engineering and delivery of the project. Within the engineering, it has very streamlined workflows which takes mystery out of programming and make it more configuration oriented. It is cybersecurity enabled. It is certified to IEC 62443-3-3, and it comes with inbuilt templates for creating dashboards, analytics dashboards, as well as for augmented reality templates. Simplified engineering in PlantPX 5.0 speeds up and eases overall system configuration. Further to that, in the concept of the connected chemical plant, it promotes premier integration with motor control, power control, and smart field instrumentation. It comes with pre-validated instructions and pre-validated and tested architectures, and it has a special capability to be able to integrate with OEM supplied equipment without any data remapping, which eases the overall commissioning effort. It has many capabilities to improve your operation. The real-time displays, which embodies all the KPIs, the alarms, and the trends, with graphics which are focused on simplicity and situational awareness based on the ISA 101 standard, and integrated alarm management based on the ISA 18.2 standard, which directs operator's attention to the specific problem where he must focus at that particular time in order to operate the plant safely. Further to that, PlantPX system inherently has flexible batch operation capability. It provides variety of batch management solution which simplify recipe and material management with ability to create multiple formulations per recipe. It has a scalable recipe design environment. Right from skits to enterprise level batching, it can provide you a very scalable batch management solution. It is easy to implement as well as to change the recipe, and while doing so, protect the intellectual property of the specific product that you are trying to make. Further to that, it has an ability to provide you data-driven visibility with standard report into how the batch process is performing. Overall, this leads to optimized asset utilization and improvement in the operational flexibility. PlantPX system provides for reduced maintenance and reduced downtime. It does so through a robust high availability architecture, whether at device level, whether at IO level, control platform level, or application software level. Further to that, the ability to diagnose a problem is enhanced through the out-of-the-box diagnostics for any system issue within the system. It also provides seamless visibility for device issues and for asset management purposes, whether the devices are instruments or the devices are motor control or electrical devices. All of this leads to better asset utilization as well as reduced downtime while operating the system. PlantPX system has special capability in terms of enabling decision makings at plant operation unit level. It has various solutions which provide in-chassis capability, like for example, artificial intelligence in chassis or machine learning algorithms in chassis. It has various solutions for model predictive control that would improve the throughput of the plant, improve the quality, at the same time reducing the energy consumption. There are solutions available in PlantPX system for embedded historian to acquire data at very high speed and to be able to store the data over a very long period of time. It further has ability to implement predictive analytics in the system, at the edge, on the premise, or even in the cloud. This leads to improved asset performance and situational awareness. So the PlantPX system has multiple different solutions for optimizing asset utilization as well as gaining operational insights for improvement of either yield or quality or productivity of the plant. Rockwell Automation has already gone through the processes and the certifications to develop the product and deliver cyber secure systems to the customer. Further to that, Rockwell provides certified system architectures so that it enables a customer to easily configure a system that complies to the cybersecurity requirement. The Plant PX system, adopts a multi-layered and holistic approach, which is based on the concept of defense in depth to achieve a cyber-secure system. This overall maintains a high level of safety without impacting productivity. So with these various attributes of the Plant PX system that we saw over the last few slides, it helps you achieve the required business outcome that we had seen in the earlier through the implementation of the connected chemical plant with the objective of achieving a digital thread through your values system. Thank you for your patient listening. And if you have any questions, we'll be happy to answer.
Can we take the poll? We have a quick poll requesting everyone to please participate. Meantime, the technology works. I'll read the first question, which has multiple choice. Select the most prominent industry challenges in order of priority that you wish to address first in your organization. Hello, Rohan. Can you start the poll? Meanwhile, once we are back with the poll question, Sandeep, you've been talked about a lot of plant pack solution. What are the few things which as an chemical organization? Sandeep, can you hear me?
Yes, I can hear you.
Yeah.
I hope you are able to hear me.
Yes, I can hear you. Thank you very much for your insights. If, there are a lot of chemical organizations who are also attending the webinar. Where do they start? All this. You share that of solutions. How and when they start, especially when this current time. When this current pandemic time. How do they enable and reach out to the technology which you have just shared?
Yeah, so in fact, over last quite a number of years, we have been working with many customers through these processes. Most customers at this point of time have taken a kind of what you may say as a phased approach. And since that approach seems to work with most customers, I would like to elaborate on that particular aspect. So when people intend to go into adaptation of digital technologies within their plant, they must do a assessment of where they stand with respect to that. Sometimes it is called as digital plant maturity model. Digital plant maturity model is something that you can go on Google and look around exactly as to what it kind of tells you, and you can rate based on the current scenario at your plant. You can rate as to where you stand in terms of the digital plant maturity model. There are, I think, 1 to 5 levels in that. We can help. We also have services within our own organization to be able to help people do this kind of assessment. Now, once people have started doing this kind of assessment, for every level of digital plant maturity that you have attained within any corner of your plant, there would be certain kind of solutions which will help you not only implement it, but show a very positive and real return on whatever effort you have put in. I'm not using the word return on investment, because if you do a small POC, it doesn't really give you a return on investment. Actually, a small project could actually be more qualified to give a return on investment in that sense. But this is how you break down the whole elephant of a problem into smaller and smaller piece and start one bite at a time. So this is a very, you might say, a consultative approach. And for that to happen, you got to be able to decide a partner with whom you would work. The partner and you yourselves would do a plant round, would do a very detailed assessment of where you stand in terms of the digital plant maturity, then look at specific use cases that you wish to achieve. And when we look at many customers that with whom we have worked with over the last few years, people have identified some specific type of problems that they want to solve. There are not many problems that people want to solve, or many types of problems that people want to solve. People are very focused on the kind of problem. Some category of problem have to do with productivity, improving the productivity of the plant, and some kind of capability has to some kind of solutions have to do with improving the asset performance or asset utilization within the plant. Even predictive maintenance comes under those kind of applications. People may decide to go for route A or route B, depending on what happens to be their priority based on their operating history. Whichever is the most pressing problem, people typically gravitate towards implementing a solution to correct that problem. And then in that particular bucket of problems, then you look at the specific use cases which can be implemented in the shortest possible time, with the shortest possible investment, if you would agree, which are ready to quickly adapt to those particular solutions, where people can be quickly retrained. This is important, and this was discussed quite a lot in today's discussion, that people orientation to adapt to new solutions is an extremely important part of being successfully and sustainably be able to use these solutions in future. We have seen that where such orientation kind of did not happen, after using it for certain time, these solutions kind of lost favor with people, and that may happen unless you have a very good sustenance strategy while implementing these kind of solutions. So that, in my opinion, was a short answer that I could have given to a very deep and long question, as I would say, over there. Hafiz, back to you.
Sandeep, if you want to take one more question, how can the connected chemical plants be positioned to justify projects?
I think that question takes us back to the concept of how do you come up with an internal justification to the management that this particular investment will give us the right kind of results. And we do realize that that's a very important problem for people to be able to handle. See, this is not every day that you have a digitization kind of project. So when you intend to go onto the path and you have selected what are the typical buckets of problems that you want to solve, you want to prove it internally that once you have implemented the thought about solution, you would actually gain something in return for that effort, which will help you more profitable and more efficient as you go forward uh, in your life of the plant. These are not simple questions to answer, and I'm happy to mention that Calypso, which is a Rockwell company we talked about a little while back, specializes in doing this kind of assessment for the customer to be able to ascertain what is the scale of the problem and ascertain how much an investment that particular addressing of that problem would take, and based on that can come up with a guidance about the path forward, including, for example, what kind of benefit, it's a kind of benefit study, so what kind of benefit would accrue to you after having implemented that kind of solutions. So they are not only in that sense implementers of solutions, but prior to implementation they would do a benefit study for you so as to be able to take that particular step very confidently. So this is a very real problem that many people face, that how to take the first step, and this is where we come in and help with our special ability to be able to provide this kind of consultancy.
Thank you, Sandeep. We have a couple of more questions that we can take, post our the next section, the next session that we have.
Sure.
With this, we have come to a very
Thanks.
interesting part of the webinar. Let me connect you all with Rockwell Automation Experience Center at Gurgaon, which is also known as DTEC, a virtual.
Hi, it's a privilege to welcome you to our Experience Center. Here, we showcase our legacy, our partnership, our capabilities, and how we propose to expand human possibility. Our offerings are a direct response to your digital need, and right from our inception, we have bet big on innovation, even as we strive to serve you. Now, let's start the tour. The fourth industrial revolution is upon us, and the digital transformation is no longer an easy proposition, nor does it arise from a single source. What it needs is a blend of solutions. We have discussed the concept of connected chemical enterprise earlier. Let's take a look how this works in practice. Let me bring my colleague, Mr. Vivek, for you. Vivek ji.
Hi, Amit.
Hello, sir. Good noon.
Good. So just to look into this concept, let me just go through the attributes of a chemical enterprise. So as today we are talking of chemical industry, let us look at the chemical industry. So in chemical industry, Rockwell has strategic alliances which are essential for digital transformation. And this is how Rockwell makes them work for the customers. So we have strategic alliance with various companies like AT&T and Microsoft on the IT layer. with Cisco on the security layer, and on the OT layer, we have alliance with ENH, Pandit, Fanuc, and our own partner network, which consists of our distributors and our customers who have domain experts and who help our customers by delivering the solutions that are required from their side. And the main benefit our customers get is that strategic alliance with global leaders like Cisco, PTC, ENH, and Microsoft, they are leaders in their own domain, and they provide solutions and services which are complementary, and we can integrate all of them together. And they are all committed to open industry standards, which help the customer in integration. Okay. Now just let us look at few of the customers who have been able to have tangible benefits while working with Rockwell. So these are the key attributes. So let us first look at the attribute like maximizing production. So an industrial lubricant manufacturer, they were able to increase their production capacity by 28% by increasing the throughput and removing the manual process with automated process. The other aspect, that is increasing asset utilization, we have an example of BASF Catalyst, who were able to increase their production by deploying a solution which was complying to ISA 88 standards, and it was a DCS which upgraded their aging infrastructure. In the aspect of improving operational flexibility, we have the example of a chemical or agricultural producer who was able to increase his productivity by 166% by leveraging on a flexible batch processing. Also, we have example of a global agricultural chemical producer who was able to reduce the rework by 5% and the batch by 10% by providing IS solution which provided visibility into the production process and was able to reduce the time for implementing the changes. So we have the example of Seco variability by implementing control solution, which helped them in increasing their capacity by 4% and consistency by 35%. So these are few of the examples which basically give us an insight on Rockwell's know-how of a chemical industry and how various customers have been able to gain tangible benefits out of the solutions provided by Rockwell. Now, looking into the key aspects which are there for this industry based on the inputs received from various consultants. So what we see is that a lot of investment is happening to end plastic waste, and a lot of customers are pursuing new product growth or service for revenue growth. Also, a lot of customers are looking at optimizing the asset utilization. They are also looking at how they ease the compliance and provide efficiency and agility in the batch production management. The other important aspect which has become very much relevant in today's scenario is remote access in this COVID times, so that they are able to operate their plant efficiently with minimum manpower. So how Rockwell can help in these aspects is the three main pillars are our DCS system, a model productive control, and our convergent plant-wide Ethernet network, which follows the security aspects. Also, we provide the full range of services, which basically starts from the feasibility and conceptual study and goes up to the upgrade and migration. So all the different aspects which are there throughout the product lifecycle, for that Rockwell provides the services. Few of the customers who have been able to get benefit out of it, some I have already discussed with them. Few other logos are mentioned over here who have been working with Rockwell, and they have been able to gain a lot of benefit out of the KPIs that they had decided that they would be achieving. So this just gives an introduction of what we know about the chemical industry and how we have been working with global leaders and helping them on this journey.
Thank you. Thank you. Excellent introduction, Vivekji. Thank you very much.
Thanks, Amit. Thanks.
Now, to begin with, let's focus on manufacturing and on the data that is getting generated. Let's move to manufacturing area. Hey, hi. Now we are into plant area, and I have a lot of things, very interesting things to show you. Let me call our subject matter expert, Vijay Bhatt over here. Hey, hi Vijay.
Hey Amit, how are you?
Great, great.
Okay, so we have been talking about the mobility. To demonstrate that concept, we have a QR code out here. So what I'll do is I'm going to scan the QR code.
Okay.
And you can see that we have the screen available. Okay, we can see that this is the mimic screen that's available out here. I can start the machine right here.
From your tab?
Yes, from my tab. Okay, it goes with the countdown and machine is ready to go.
Great.
So this is the concept of mobility we have been talking about, and we are actually demonstrating it, that just having a tablet in hand, I can operate a machine, I can get the screen, and I can operate it.
Wow.
Using a QR code concept.
Fantastic.
Here. We can do much more things. Let me take to the next machine and show you the remote capabilities also. Let's go.
Yes, Vijay?
So Amit, let me show you the power of remote connectivity here. We have an RFID scanner here. Okay. And I have a maintenance access and an operator access.
Okay.
Now, based on the access that is given to the person, we can access the machine which is at some different location.
Correct.
And use a different machine HMI out here also.
Okay.
So I have an operator access, I scan it, and you can see that I have an HMI available of a different machine here. I can start stop.
Yes.
I can start stop it. I'll first reset it, and I'm going to start it. Now the countdown begins and machine will start shortly. You can see the machine is now ready to run. I can also stop the machine right from here. Just by issuing a stop command, I can stop the machine also. Okay. Yep. So the machine is stopped. So this is the power of remote connectivity.
Is there anything installed here?
There is nothing installed here. It's a zero client. There is no software. There is no license into it. And it is very much safe. It is end-to-end encrypted. And if you have this infrastructure available at home, you can access it right from your home also.
Oh, great. That's fantastic.
Wonderful. So this is not the enough. I'm just going to show you something more. Let me take you to the next kit. Okay. So here we have a machine, and now I'll show you the concept of augmented reality. So what I'm going to do is I'm accessing this machine. So now here we show the power of the augmented reality. So I can scan this whole machine, and you can see that we have different gauges available, which talks about the different parameters of this machine. So if we have a new operator or new trainee and we want to train him on various aspects to locate the different parts of this machine, we can also do that. Like I can go to the mixing tank here. I can select and go to the agitator here. I can also go and see where the feeding pump lies. So he can see the location of different equipments in the machine using the augmented reality. So that's the strength, the power of the augmented reality concept.
Great, Vijay. Thanks a lot. Thank you for that insight.
Most welcome. Thank you.
So now what you have seen is the power of mobility, remote connectivity, and the security. For that, I have a subject matter expert, Vikas, for us. Vikas.
Yeah. Hello, Amit.
Hi, Vikas.
Yeah. So today we're going to show you the integration of PlantPX GCS with one of our process kit.
Okay.
We are basically having different third-party instrument like ENH instrument. So I will just open this one of the screen. So basically through integration, we are able to get all the diagnostic data. Then also we can have the remote maintenance. Like in this case, we can do a heartbeat test. So that will run a test on the different components of its like coil and the transmitter, etc. And then we'll generate a report.
Oh, it's an instrument health.
Yeah. So we can remotely monitor a instrument health. Okay. Then further we can have integration with power components like VFD. Like in this case,
okay.
This is our 5-to-5 drive where on the pump. Then next we have the integration with the overload relay.
Overload relay.
Yeah. So this is the integration with power components. Similarly, we have also installed a condition monitoring system on pump and the agitator. So I will just start the batch.
Okay.
So we have basically we can monitor different parameters from the condition monitoring system. So I can just I will just open the trend page where we can see the vibration parameters for different base frequency, etc. So this is basically the integration part for the PlantPX DCS with the various equipments. So let me touch upon a next topic, that is a security aspect. So basically, cyber security is a very important aspect whenever there is a integration between IT and OT layer. So I will just showcase that how Rockwell is going to have a defense in depth approach to maintain the cyber security compliance. So basically, we are having our controller that are SIP security enabled. So where the unauthorized access is disabled. So if anyone have the access for the to the panel and then try to change the mode of the controller, then there will be a alarm detected and that will be logged, and that shows to the operator that there has been a security breach and unauthorized access has been done.
Great, great.
So I will just reset it. Similarly, at the network level side, so at the switch level, unused ports are already disabled.
Okay.
So whenever there is a unauthorized access, so if I try to use this cable to access the live port, so if anyone try to access through the live port, then also we get the security breach because only the authorized system can access through this.
Only
switch.
authorized person will get access.
Yes.
You have a lot of instruments, lot of power control devices, lot of condition monitoring hardware. These are generating huge amount of data. Where this data going?
So this data is going to this industrial data center where we have implemented the virtual environment. So basically we are logging all the historical data and all the SCADA control, etc. on this virtual environment.
Great.
So let me just guide you to the command center. Yeah, so this is our command center where basically we are having a video wall where the data is coming from different plant sections. Like you have seen the process skid, and then next is the HMI from pick and place, and then the IoT platform. So basically this is a tile view where I can have the data from different plant section, and then I can select. If I want to go to the different screen, then I can select one of the screen and it will explode.
Oh wow.
So next I will again change it to the tile view. So I can select different plant section and then I can operate it. So let us sit and then have the demo on plant PX DCS.
Sure.
Yeah, please have a seat. So let me just change tile view to my DCS demo. So I will just yeah. So this is a chemical demo for our plant PX DCS.
Okay.
Yeah. So this is how a typical chemical plant will look, having the different areas like starting from the raw material handling. Then we have the prep tank area. Next we have the product storage. And then in the we have a batch process in the reactors.
Reactor area.
Yeah. Other components like dryer and then the tank area. Yeah. And then next in the separation area, we have the continuous process. So let me just go through, take an example of batch process. So in our plant PX DCS, we are having S88 compliance batch solution. Okay. So this is example of a reactor where basically we are having a status of different phases. These are different phases of reactor. So I will just go to the detail of a batch overview where I can monitor the batch running on a reactor. So okay. I can have the option to create a new batch where basically I can select a recipe from the master recipe database. So in Rockwell, similarly, we have solution for integrated safety. We can provide a seal level controller.
Great.
For system where we require the integrated safety. So that's all I have for this chemical plant DCS demo.
Oh, great, great, Vikas. Thank you for your demonstration. So now let me bring an expert on the analytics to explain us how on our DCS the analytics solutions are going to work. So subject matter expert with us is Anshu.
Hi, Amit.
Hi, Anshu. What do you have for us today?
Okay, so let me demonstrate the analytics part. Sure. Okay, so starting with the analytics, the first device, as you can see, the first dashboard talks about the overall health of all the hardware connected to that particular system. All? Yes, all. Everything which is connected and communicating over Ethernet IP. Okay. So as you can see that this particular device, it can handle up to 100 items or 100 devices. Okay. This particular device has currently 53 devices connected. Okay, correct. And if you want to further monitor the health of all the devices connected to it, you can click on any of the devices which are listed over here, as you can see that. So this one, for example, it talks about the L85E controller, which is basically a L8 series control logics controller. So you can see the information brings to it, controller utilization, messaging utilization, IO utilization, and there is a feature, wherein you can filter in for any of the particular devices. For example, there is another controller which gives you another set of data like a control logics L72 controller, wherein the information is collected like free IO memory, free logic memory, total CPU, Great. Idle CPU. Great. And not just that, it also has another set of devices like Ethernet switches. So you can see that. When it comes to different type of devices, the analytics, slightly varies. Say for instance, in case of a static switch, the information it provides is like bandwidth utilization, the total bandwidth utilization, and the internal temperature. Temperature of the switch? Temperature of the switch. Okay. Which can come very handy specifically for the maintenance personnel. Correct. And not just that, it also has a feature of, providing you the action decks. So when I say action decks, so whenever there is an issue with a particular device connected to that diagnostic setup, so you can see that, the diagnostic condition detected for all the devices, which needs some attention from the personnel are very clearly listed over here. In addition to that, there is a feature called vote down and vote up. Say if you find, this particular fault or action deck is not relevant to your system. Okay. So you can just vote it down, and the moment you vote it down 3 times, it just moves out and it will not appear it over here again. Okay. So this was just a quick overview, a glimpse of the device analytics or the information related to device analytics, which basically brings the health related information of all the hardware connected to a system. Correct. Now let's move on to the next topic, which is basically the predictive analytics part. Oh, okay. So when it comes to the predictive analytics, so as you can see that this particular demo, it talks about a series of connected pumps. Okay. Right. And this particular demo, it's based on predictive analytics, and it also implements the machine learning model. Right, which brings the advantage of predictive analytics. Okay. So as you can see that, this main dashboard or the home page, it talks about all the pumps connected to that particular demo, and it provides you a quick glimpse about the model number, the serial number, and the analytics related to it, like the mean time between failure, correct. Its availability, and it also provides you the alerts whenever there is a low discharge value. So when I say low discharge, the assumption over there in this particular demo is, so whenever there is a the discharge pressure is too low, correct, it triggers an alert to the user. Absolutely. Right. And if you want to further drill down and find out much more information about any of the particular pumps, for example, this one, pump C, is having some alert, and if you want to find out the analytics about this particular pump C, so you can see that the moment you open the detailed page on analytics about this, so you can see that there are different type of tabs available. The first one is the SPC view. Okay. Statistical process control view. Correct. Wherein you can have the vibration related data, right? The X bar chart, the R chart for all the parameters. And not just that, you can also have live monitoring, right, for all the critical parameters like vibration, seal flow rate, pump jacket temperature, pump current, right? So the parameters are plotted over a graph, And then
this is right now real time.
Yeah,
as
this
well
is
as a historian also I can have.
exactly. So this one is the real time. And when it comes to the streaming analytics, it provides you the raw incoming data, streaming analytics, wherein you can find out the min, max, mean of all the critical parameters.
Correct.
And not just that, I mean the standard deviation from the normal values. And not just for one parameter, for all the parameters like current, seal flow rate, jacket temperature, vibration. All you have to do is just click on any of the tabs and you can monitor that.
Anshu, what you are describing right now is a pump model.
Right.
Would it be implemented for a compressor or a reactor or some kind of an...
Sure, why not? So the same model or concept can be applied to any of the assets.
Okay.
Whether it is manufacturing area or process control area. So
Wow.
the same concept of machine learning can be applied over there.
Fantastic.
Right.
Great.
So now let's move on to the next topic, or the next part of this particular demo, which is the most important one, which is the predictive analytics part.
Okay.
So as you can see that this particular dashboard, it talks about this basically utilizes the machine learning model, right? Wherein you can see that, it plots a bubble graph for the actual results as well as the predicted results, right? So bigger the size of the bubble, more number of data points. And you can see that, the metrics it uses to predict that model, all the major ones like Pearson correlation coefficient, and root mean square error value, root mean square normalized, and R square adjusted. So you can see that, the root mean square value, or rather Pearson correlation coefficient value, it is close to +1.
Okay.
So that shows the confidence, how good that particular model is.
So this is plotted on the data we have available in our plant.
Exactly. And you can see that, the accuracy level, it is 99.96% accurate.
That's amazing.
Right. So that was a quick glimpse about the predictive analytics, referring to a demo.
Fantastic. Fantastic.
Yeah.
Thanks, Anshu. This is a great demonstration. Thank you very much.
Welcome.
So now you have seen the analytics part. Now let's move to a virtual reality section. Hey, hi Farhan.
Hi.
You're supposed to be in factory.
So we'll go together.
Is it?
Yeah. Let's go inside our factory.
You are about to enter the only staging and development facility in India. Here, engineer solutions which are supplied to domestic as well as international customers. This facility is spread over 48,000 square feet and employs about 250 people. This facility offers engineering, staging, and testing of process automation panels. On the first floor of our Sahibabad facility, we have the engineering center. Here, over 100 engineers carry out design and development of project deliverables. Here, we also have an adequate development lab, where we develop prototypes to demonstrate our technical expertise on Rockwell products and solutions. To enable our engineers to develop customer-centric solutions, this lab is equipped with a complete Rockwell product portfolio. The main panel assembly area is spread across 5,700 square feet of the ground floor. It is capable of delivering 150 cabinets at any given point of time. This facility also offers total capacity of 2,500 cabinets per annum. The entire assembly and wiring activities are carried out by highly skilled workforce following RA.
Analytics shows in the demo which you have shown can run only on PlantPlex or any other DCS platform.
Yeah, that particular question I did actually answer as a part of the chat.
Okay.
The shown analytics are a part of Plant PX, number one. The analytics actually are created by a device we called analytics for devices. It's a hardware device. It has recognition or ability to recognize more than 2000 different components, industrial components, which are available either from Rockwell or Rockwell partners, which connect on Ethernet IP. And it automatically goes on the network, identifies those things, and then automatically creates those analytics that we saw. Okay. Now, while Rockwell and the device that we have has this capability, incidentally, just to mention that the device that we are talking about also has a chatbot. So a chatbot on a DCS would be something, I mean, people are familiar with the advertisements of Alexa. So this is like chatbot like Alexa available on a DCS system, one could say. But while it is not impossible to build such analytics for anybody else's system for that matter, obviously the richness of the analytics that is provided would depend on how much of an information is easily accessible and can be pumped into an analytics platform to build such dashboards. So that is what my answer would be to that particular question.
And Sandeep, also if Amit Bhujbal is there, what is the cloud storage provider recommended, which is uh, response to us is AWS, which is Amazon Web, Azure, or any other. Every service provider may have a data, stored on different clouds like AWS. Are they all secure? Which Arjun wants to know?
Yeah. So we have implemented solutions on all cloud providers. So we are agnostic to which cloud provider you want to use. We have implemented on AWS, we have implemented on Azure. So we are comfortable whichever is the technology choice that the end user company wants to take up, the solution actually is able to meet that requirement. Now the question really here is, I think whether it is secure or not. So from that point of view, it's security is entirely your own thing, in that sense that how secure you want to build your system. You have necessary components and technologies available to build that level of security within your platform. Security is not one solution. Security consists of number of different solutions. All of them will need to fail simultaneously if your platform has to get compromised. Okay, so this is how you build security through or the defense in depth concept is exactly that concept. You don't rely on one piece of solution to build your security, and every cloud platform that we know and every component that we sell and configure has this ability to build multiple layers of security so that all of them cannot be breached at the same time. What we have done is, as an answer to that particular question, we have provided certain links about how, for example, our partners Microsoft and their platform Azure, how that Azure platform provides security. We have provided certain documents, so please go through that for more details. And obviously we are always available in case you want to have a longer discussion on that particular topic.
Sandeep,
Okay.
be online. Meantime, we can continue. We start that virtual tour.
Thank you, Farhan. Thanks a lot. Thank you. Can we use this technology in our maintenance and repair? Let's check with Vijay how he can help us.
As you see that we are getting a guided instructions to first remove the front top cover by removing the 4 screws. Next, we'll check the DC bus voltage. It has to be 0 volt at the guided location. Third thing is that we will disconnect the jumpers, to ensure that the jumpers have been removed and isolated with the system. Then we'll remove the capacitor cover. There we can see the location of the screws which has to be removed to remove the cover cap. Then we'll carefully unplug the power terminals, as you can see here, it is highlighted. Then we'll remove the fan assembly. You can see the screws for it, how we have to remove them. Okay, it shows the location also. Then we'll remove the human interface module, so it shows the location of the screws. So once the HIM is removed, then we can access to the power interface board. We find the location of the screws and connectors which are to be removed, and once they are done, we can remove the power interface board, faulty power interface board in the drive, and then reverse the process or place the new power interface board on the drive.
Thank you for being our privileged guest and showing interest in this walkthrough. It was a lovely experience demonstrating you what we are passionate about. We look forward to partnering with you.
Sandeep, hope you are there.
Yeah, I'm here.
Yeah, so I think if we can take a couple of more questions from the audience, which is a question to you only. When you have a very partially automated plant, where do you start digitalization journey?
Sparsely automated can have multiple use of actual implementation. Digitalization as such is information hungry, and therefore specific amount of based on the objective that you have. For example, your objective could be improvement in productivity, your objective could be improvement in quality, your objective could be for that matter improvement or reduction of downtime on a specific piece of equipment or unit. And whatever is your primary objective, which is what is causing you most trouble during night, let us say disturbing your sleep, based on that particular behavior of that particular unit and the objective that you want to achieve, one could possibly do a walk around and decide if the instrumentation and the measurements that are available along with that piece of equipment are sufficient or not. Now, for example, you may not actually have online instrumentation for all the measurements that are due over there. But if some of the parameters could possibly be manually entered and manually measured, those two can contribute to estimate of the performance phenomena that you are looking for. And one can look at those kind of scenarios and decide that, okay, these many instruments I want to have online, and let us say they are online, and these many measurements I don't have online, I cannot invest in that right now. But let's say that I have offline kind of measurement instrument that I can do at repeated at specific periods, so that that will help me build my model with respect to that particular unit to help me do the analytics functionality that I desire to do. This was just one example of somebody. When somebody says sparsely instrumented plant, this is just one approach of getting around to doing that. Now, when you talk about so many measurements being done manually, and therefore then you have to have, number one, the manual instrumentation that is required to take the measurement. You have to have so many spare people. If you have spare people, obviously this will work. If you don't have those spare people, don't have the systems to be able to deploy those kind of people, then obviously you will look at what other alternatives are available to you, or you might actually switch to a different problem where such instrumentation can be made available. That was a very difficult question to answer, I should say, and every question needs a different view to be able to ascertain what is the best way out of that particular situation on that particular unit. And that can only be done when the customer and a partner like ourselves take a walk through around that, understand what the problem is that we are trying to address, understand what kind of measurements are required to be able to address that particular thing, what technologies are available to address that particular problem, and then come up with the best way forward, which is most economical and efficient to be able to reach there in the shortest possible time.
Perfect. Sandeep, that was very brief. Thank you very much. And I think we have exceeded the time, and there was some technical issue. I apologize on behalf of manufacturing today and ITP. And I'm sure there will be a lot of questions from the audience, and you can send the questions to us. You can reach out to us. We will connect you to the Rockwell Automation team. With this, Sandeep, I think the session was very filled with insight, experience, real-time live scenarios, and much more. We appreciate all the speakers, the panel 1, panel 2, all Biju and Sandeep, to you. Your commitment and dedication in sharing the insights to the industry, which means really a lot. Additionally, the thought-provoking questions from the audience made the discussion very live. We hope it was a learning experience for everyone in the summit. Thank you very much, and we look forward to reconnect with you in the next subject next time. Stay safe. Thank you very much.